Hello, my Calc 3 student. So sorry, I'm posted chapter 15 before we finish. I posted chapter 14, and today I hope I finish posted chapter 14, section 14.7 and 14.8. 14.7, triple integrals in other coordinates. If you have some triple integral in rectangular coordinate, okay, from some object f function depend x, y, and z dv, then you can move for cylindrical coordinate system, and then you happened angle changing from theta 1 to theta 2 are changing from some function h1 depend theta and h2 depend theta. Z change from some function who is depend r and theta. Okay. G2 r and theta. Then for function x, you substitute with r cosine theta. R cosine theta. Y, you substitute for r sine theta. R sine theta. Oops. Sine theta. Z is still Z. And then you need multiply it by r and take it to order integration. It will be dz, dr, d theta. Sorry, it's not staying the one line. Okay, now solving some example and see how it's work. I'll clear my table first. We need found volume object when you have some sphere x squared plus y squared plus z squared equal 4. This means you have sphere radius 2 and some cylinder where it says r equal 2 sine theta. If we try see what kind of picture we have, this will be some sphere and cylinder inside and something like this part and this part and this part of your cylinder. This is more okay, and you need found this cylinder. Great. Now we try solving what kind of information we have. Okay, I clear this picture because I need space. How you remember r square, it will be x squared plus y squared. Use this fact. You can see if you plugging r in your equation, your sphere, you have r square plus z square plus z square equal 4. This means z changing between negative square root from 4 minus r square and positive square root 4 minus r square are our change. Sorry guys, between 0 and 2 sine theta. And how changing theta? Theta change between 0 and half of pi, because when you see in the picture, when we go to xy plane, we have this kind of circle. It will be 2 sine theta. This means for 0 it will be 0. For pi over 2 it will be 2. Here it will be 0. And this is will be oops. We don't need picture or anything because sign are changing. If r changing, if r is positive, your theta is between, okay, I'm clear here, theta is between 0 and pi. Sorry, theta is between 0 and pi. This is all possible value where sine theta is positive, and this means r is positive. And now we are ready for write our volume integral. Volume, it will be triple integral for our cylinder dv. Or if you remember formula, it will be integral from 0 to pi, how changing theta, from 0 to sine theta, how changing our r, from negative square root 4 minus r square, and positive square root 4 minus r square, if how changing z. And then we have r, dz, dr, d theta. Okay. Take this integral. We have integral from 0 to pi, from 0 to sine theta. It will be z here, and if you z plugging, after integration you have z. If you plugging root minus root, we have two roots. This means I have r, 2r square root 4 minus r square, and there r theta. If you want, you can use u substitution here. 4 minus r squared, it will be u, minus 2r dr, it will be du, and you can easily evaluate. Or without any substitution, you have integral from 0 to pi, negative 2/3, 4 minus r squared, and new power, it will be 3/2. And then we need plug in 0 and 2 sine theta. 2 sine theta, and you have d theta. Continue. Simplify all of them, and plugging, you have, I think you can do it this way, or you can looking for book. You have 16/9, because this is very simple integral, 3 pi minus 4. Great. See some example how we can use spherical coordinate system. Now I clear here. Let's go. We need found some part of your sphere and your cone intersection part. Okay. Just a moment. It takes so much time. Oop. Okay. Now we need found volume, but before we looking for formula, if you have triple integrals and our XYZ system, rectangular system, and you want to move for spherical coordinate system, then you have integral from theta 1 to theta 2, from phi 1 to phi 2, from rho 1 to rho 2. Then you need to remember fx is substitute with r sine phi cosine theta. R sine phi cosine theta. Y will be r sine phi sine theta. R sine phi sine theta. And z is r cosine phi. R cosine phi. And then you need multiply your function for rho square sine phi 0 d phi d theta. This is how we move from rectangular to polar coordinate system. These are some examples. Oops, sorry. Okay, we try found volume whereas you have below z square equal x square plus y square and above x square plus y square plus z square equal 9. This means something. First one will be cone and second one will be sphere. Because x square plus y square plus z square equal rho square, this means you have, from here we have rho square equal 9. This means rho changing between something, a rho equal 3. Okay, equal 3. But remember, because x square plus y square equals z square, plugging for our second equation, first one, we have z square plus z square equal 9. This means z equal 3 over square root of 2. And remember equation for z, where z is r cosine phi, z is r cosine phi. We have for cosine phi equal 3 over square root of 2 times 1 over 3. This means maximum possible value cosine phi is square root of 2 over 2, or 1 over square root of 2, and phi is pi over 4. And now we have borders our variable. This means row changing from 0 to 3. I write up part because I'm trying safe after I'm clear. Row change between 0 and 3. Phi change between 0 and pi over 4. And theta change between 0 and 2 pi because we have circle and cone here and don't have any problem. This means theta covered all possible value. Theta change between 0 and 2 pi. Now we're ready for write integrals. I clear all of them except our borders. And see what we have in our volume. Okay. Here we have our volume. It will be, it's triple integral dv, or integrals 0 for 2 pi, integral from 0 to pi over 4, and integral from 0 to 3 r square sine phi dr d phi d theta equal. And here we have integral from 0 to pi, integral is 0 to pi over 4. R squared give us r cubed over 3. And we need plug in 0 and 3. Sine phi d phi d theta. If you plug, you have 27 over 3. This is mean 9, or 0, it will be 0. This means we have 9 integral from 0 to pi. And then we have integral from 0 to pi over 4 from sine phi d phi. Sine phi d phi will be negative cosine phi, negative cosine phi. We plug 0, 0 pi over 4. The theta, it will be 9 minus square root 2 over 2 and plus 1, and the theta give me exactly 2 pi. You can simplify, if you can stay this way, it's no problem. We finish. Now solving couple of example from book. It help you solving your homework. Question 14 from section 14.7. Okay, I clear here. Just a moment. Okay, oops. Here I need evaluate integral with from 0 to 2 integral from 0 square root 4 minus x squared integral from 0 square root 16 minus x squared minus y squared, and function is square root from x squared plus y squared dz dy dx. Looking here, now number 14 you have exactly in the book, you have moved to cylindrical coordinate system and then solving. But how we can see we need move to exactly in cylindrical coordinate system? You have x and y always squared and added or something like this, and border your integrals is half x squared and y squared, and your function is half x squared and y squared. This means you need move to cylindrical or polar. But because you don't have any z squared here and any z, this means cylindrical is work better. Okay, how we have, what kind of information we have here? Z is changing from 0 to square root 16 minus x squared minus y squared. But how you remember x squared plus y squared, x squared plus y squared is equal r squared. This means our z change from 0 to square root 16 minus r squared. Great. Now we need checking how changing x and y. This time we make some picture. XY axis, x, y. Because y is equal square root 4 minus x squared, y is equal square root 4 minus x squared. This means y squared plus x squared equal 4. This means I have some circle, and now we need checking what part you have. Y change from 0 to border your circle, but x change from 0 to 2. This means x change from 0 to 2 and y change from 0 to border. You have this part. Okay, what you have here? R change from 0 to 2 and theta change from 0 to pi over 2. R change from 0 to and theta change from 0 till pi over 2. And now we're ready to rewrite our integrals. Okay, I clear a little bit. And we can, you see, we not build all graphs because we don't need, we only need some last part projection for xy plane. Okay, this means our integrals now is, after we solving, we study new borders, will be 0 pi over 2, 0 2, then 0 square root 16 minus r squared, and here we have square root from x squared plus y squared, but x squared plus y squared is exactly r squared. This means you have square root from r squared, it will be r. In the formula you have one more r, this means I write r squared, and then I have dz, dr, d theta. Continuous solving, we have integral 0 pi over 2 0, 2. You have r squared z, but because z is you plug in, you have r squared square root 16 minus r squared dr oops, dz. Counting this integral or use trigonometrical substitution or use table, we can counting is will be okay, maybe I'm show you how it's counting. It's taken so much time, but okay, integral from 0 to 2 r squared 16 minus r squared dr. Here I use substitution, trigonometrical substitution. R will be 4 sine theta, 4 sine theta. Sine theta is, we have, this means 4 sine t will be better. And the r will be 4 cosine t dt. New borders is will be 0 if 4 sine t equals 0, this means t equals 0. If 4 sine t equal 2, this means sine t equal 1/2 and t equal pi over 6. And if you plug, you have 16 sine square t cosine, 16 cosine square t dt. What happened with d? I don't know. That's it. Here we have sine square cosine square product and both of t. This means you can use twice trigonometric identity for sine twice. And you have here, it will be 4 go inside, 4 and 16. It will be 64. Integral from 0 to pi over 6. It will be sine square 2t dt. And now we can use trigonometric identity. We make your power is 1. It will be 32 integral from 0 to pi over 6. 1 minus cosine twice 2t is mean 4t dt. Here is found integral is not problem. You have 32t minus cosine, this means will be plus 8 sine 4t. And then if you plug in your border 0 and pi over 6, you have 16 pi plus 4 square root of 3. Go back with our double integral. Okay, I've saved this part and plugging. I clear all of them. Oh, just a moment. We have 16 pi plus 4 square root of 3. Because it's coefficient, I can take it out. 0 pi over 2 dt theta, who give me this integral over only pi over 2. If you plug, you have 8 pi square plus 2 square root of 3 pi. This is our final answer. One more question, one more example. Okay, this is clear now. Example when we move from rectangular to cylindrical coordinate system. Just a moment, I clear. Ooh, sometimes it's taking so much time. Okay, guys, 3 students don't send me your quiz. What happened to you guys? Okay, we have some object and we need found volume if it stay between x square plus y square plus z square equals z. This is question number 34 from section 14.7. And z equal square root from x square plus y square. And here we need move to spherical coordinate system. Okay, first equation give me x square plus y square plus z square exactly rho square. This means rho square equal z. Use this equation one more time and looking for second one, whereas z equals square root from x square plus y square. This means z square is x square plus y square, and plugging for first, we have z square plus z square equals z. 2z square minus z equals 0. Z out to z minus 1 equals 0. This means z equals 0 and z equal 1/2. If we use this fact, we now, and plugging rho square equal z, this means here we have rho equal 1 over square root of 2. Great. Remember formula for z, where z is cosine phi. We have, and plugging there, we have 1/2 equal 1 over square root of 2 cosine phi. Cosine phi equals square root of 2 over 2. This means phi equal pi over 4. And now we're ready for write our integrals for volume. Okay, I clear all this counting. And see what we have. Just a moment. We have our integrals will be from 0 to 2 pi, from 0 to pi over 4, because we found maximum possible phi, and our maximum possible is 1 over square root of 2, and because it's always positive, non-negative at least, this means from 0. And then we use formula for moving spherical coordinate system as rho square sine phi 0, d phi d theta. Use this fact and integrate. We have integral from 0 to 2 pi, integral from 0 to pi over 4. Here we have rho cube, and if you plug in, it will be 1 over 2 square root of 2, rho cube over 3. This means it's multiplied by 3 here. Okay, and sine phi d phi d theta. Here we have 1 over 6 square root of 2, 0 to pi. Integral from sine, this will be negative cosine phi d theta if phi is 0 and pi over 4. It will be 1 over 6 square root of 2. Cosine we have negative square root 2 over 2 plus 1. Because cosine 0 is 1, negative 1, you need subtract. And d theta, integral from d theta is theta, theta changing from 0 to 2 pi. This means we have multiplied 2 pi. We can little bit simplify, or we can rewrite this way. It will be 2 minus square root of 2 over 6 square root of 2 times pi. I think it's good enough. Do your homework, write me question, and I think I make it Zoom office hour Thursday and Friday. I hope it's better work for you. If you have any suggest what time it will be, write for my email.